We've done this experiment before in the previous video where we used iodine and ethanol to produce ethyl iodide, but trying out aluminium foil instead of the classic but hard to obtain red phosphorus. Today we're going to do it again, but this time using methanol. If it works, the product should be methyl iodide. So first up, here's our iodine. We're using 40 grams. Instead of the cute little balls, we're using iodine which we've recycled from previous reactions, but it's been dried pretty well and it's definitely pure. Now for the aluminium foil. We've weighed out a folded up sheet here which is 4.5 grams in weight. This is in excess to what we need theoretically, but we want to make sure that the iodine has a good chance to react properly. That's our dry ingredients. So let's have a look at the setup for the reaction. We've got the 250 ml flask set up with a reflux condenser, sitting on a hot plate stirrer. Last time we did this reaction using ethanol, we noticed that there was a lot of heat generated. Since methyl iodide has a low boiling point around just 40 degrees C, it's going to be really important to use a very efficient condenser with very cold water in there, otherwise a lot of the product could escape. So we're going to use super ice cold water for the condenser. Let's power this up using our mini aquarium pump and silicone rubber tubing. Again, we're not sure exactly how vigorous or exothermic the reaction will be. So in order to moderate the temperature, we're also going to use a cool water bath. We detach the condenser temporarily. And let's first add all the solid iodine to the flask. Here we go, all in now. And now for our methanol. In theory the reaction only requires about 13 ml of alcohol stoichiometrically, but we're going to use 50 ml. The reason being that we want there to be some liquid in here which can boil and stop the iodine and aluminium reaction getting out of control. Let's get it in. Some of the iodine dissolves in the methanol, forming a red-brown colored solution as you can see. Let's get stirring. Okay, just one thing left now. We've scrunched up the aluminium foil into little balls, which should control the rate of the reaction a bit as well. So let's do it. We've put them all in and now we've got the condenser back on again. Let's keep stirring now and wait and see what happens. No sign of any obvious reaction to begin with. But aluminium metal always has a very thin outer layer of aluminium oxide on it. This fools you into thinking it's not a very reactive metal, but that's not the truth. It's actually very reactive once this coating of oxide is gone. So we'll keep stirring and wait. After just a few minutes, here we go. The reaction's starting up. And pretty soon we can see that it's exothermic because there's some methanol condensing in the flask. Soon we've got our first droplets of something condensing. Perhaps methanol, perhaps methyl iodide. The reaction is getting more vigorous, but not out of control. The temperature is slowly rising in the flask though, but it's under control with the water bath. The ice-cold water has caused some water droplets to condense in the top of the reflux condenser, but they're not going down into the flask, so this seems okay. We're not sure how water-sensitive this reaction is. If any water gets in, we imagine it would react with the aluminium iodide intermediate very quickly, generating hydriodic acid. This in turn could also react with the methanol, forming the product. In theory anyway. Well, the reaction if anything seems to be slowing down after about 30 minutes, so we decided to cautiously take the flask out of the water bath and allow it to naturally warm up with the reaction. Let's see if it blows up or not. It didn't. The flask gets quite warm but the reaction just chugs along. In theory, if the reaction is like its red phosphorus counterpart, the aluminium and iodine form aluminium iodide, and this then reacts with the methanol forming aluminium hydroxide and methyl iodide. But we can't explain why, but it just doesn't feel like that's what's happening here. If lots of methyl iodide was being produced, then we'd expect to see a lot more refluxing at the warm flask temperature. We let the aluminium foil react for another 30 minutes. You could start to see specks of metal floating around in the mixture. And the aluminium was definitely dissolving and forming a more yellow-colored reaction mixture. At this point, after an hour, we decided to rearrange the apparatus and set up now for simple distillation. We'll heat the flask now on the hot plate and distill off both the excess methanol and also any other volatile products in here as well. Surprisingly, the distillation of the flask contents did take quite a long time. The bulk of the solvent comes off fairly quickly and condenses as a colorless liquid. We're using the receiving flask cooled in ice water so as to minimize any escape of methyl iodide, and we're also using the same ice-cold water in the condenser as before. It takes fairly strong heating to get the solvent to come off efficiently, and we insulated the flask with foil. Here we are with about 30 ml of liquid condensed. Let's add some water to this and see if we've got some methyl iodide in here. The milky color is a good indication that we've got something becoming insoluble on addition of water. And allowing to settle for a bit, we've got a lower layer appearing in the bottom of the flask. But not very much. So let's continue distilling. A slurry is produced and distillate is produced even on quite strong heating. So let's keep going until the boiling flask is as dry as we can get it. Well, that took a further 3 hours and quite substantial heating until no more liquid came off. Let's add the remainder of the distillate to the previous aqueous mixture. We actually drained off the top layer in a flask containing water and methanol and replaced with water. We'll leave this to settle and for any crude product to sink down to form a bottom layer. Here's what's left in the flask. A fairly dry solid with some bits of recognizable aluminium foil in there, but mostly a strange amorphous dark solid. It's also got a slightly unpleasant sulfur-like aroma, possibly due to some sort of contamination from the aluminium foil, although it's the same foil we used for the previous ethyl iodide reaction. It doesn't react at all obviously with water, so there's nothing exotic in here and no aluminium iodide obviously present. Here's our distillate and water mixture. There's definitely a bottom layer in here forming. Let's get this into a separating funnel. Okay, let's drain this bottom layer off. And we'll use some calcium chloride granules to dry the crude product. It's pretty dense as you can see and the balls float on the surface. Now we'll decant this into a container for weighing. It's a bit of a disappointment. This is clearly crude methyl iodide, but it has a more poppy aroma than usual, so it's not as pure as we're used to. But there's not that much. In fact, we've got 14.6 grams, which if pure represents a 33% yield on starting iodine. This is less than half the yield we got with the ethanol reaction. So where did the iodine go to? We're pretty happy at this point that we had ventilation going. Perhaps the methyl iodide is just so volatile that it escaped out ice-cold condenser. Perhaps the reaction is much more water sensitive than we think. Or perhaps this process using aluminium foil simply doesn't work as well for methanol as it does for ethanol. Well, we could distill this crude product, but there's not much of it, and so we'll wait to do this another time. If you want to give this a try, we recommend perhaps skipping the refluxing stage and distilling the reacting mixture right away, as well as making sure everything is super dry. But don't expect amazing yields. Thanks for watching and stay tuned when we'll be back in a month.